Now, guys, I'm gonna move to the part of normal and tangential coordinates in kinetics, and I'm gonna solve a problem on this issue. Okay, so here I have a curvilinear motion. All right, I know the equation of y in terms of x, and this will help me in finding the radius of curvature. All right, and I know the of this car, it is a 0.8 megagrams, which means it is 800 kilograms. Car traveling over the hill having the shape of a parabola. If the driver maintains a constant speed of 9 meters per second, so the speed is constant, which means AT is equal to 0, right? Because I know that the tangential acceleration is always standing for the change of the speed, while the normal acceleration is standing for the change in direction. Determine both the resultant normal force and the resultant friction force that all the wheels of the car exert on the road at the instant it reaches point A. And I have to neglect the first. What are the forces exerted on this car? In fact, guys, this car has a weight, and it has a normal force that is perpendicular to this tangent line to the curve, all right? So this normal force is perpendicular to this line that is tangent to the curve, which is the direction, okay? What else do I have? I have also the frictional force. So I'm gonna call it FF, which is equal to mu k times N. Do I have any other force? Do I have any other force, guys? What do you think? Do I have any other force? What do you think, guys? I want you to say, guys, you're hearing me? Abbas, what about the engine force here? What about the engine force? Right? The force of the motor. What is the engine force here? What about this engine force here, guys? In French, it is la force motrice. What about the engine force here, guys? Do I have an engine force? In fact, no, because I am traveling over the hill and I have to find the resultant friction force that the wheels of the car exert. As if, guys, there is no engine force. يعني أنا حتى أجري على الفرامل. All right? Okay, guys? Or you can understand this fact by another way. If I put this engine force here, F, the resultant friction force here of this problem will be FF minus F. Okay, so it is the resultant force done by the wheels. It is the friction minus the engine force. All right, guys? Okay? Okay, guys? So you can understand it in both ways. What I'm gonna do is to remove this engine force. I'm gonna assume that there is no engine force because in fact it is traveling over the hill under the action of gravity. So I'm not gonna put this motion force, all right? As if this driver is doing a brake, okay? Is putting his legs on the brakes. All right. So guys, what I'm gonna do now is to make first to put the tangential direction and the normal direction. So of course the tangential direction will be tangent to the curve, so this is the tangential direction, and of course the normal direction will be perpendicular to this tangential direction to the center of the radius of curvature, so this will be my N. Okay, guys? So this will be my T and this will be my N. Now what you have to know, guys, that always in curvilinear kinetics, when I have the equation of y in terms of x, when I have the equation of y in terms of x, First step, guys, find the angle between T, the tangential direction, and x-axis by what? By finding tangent alpha as dy over dx at this x. Right, guys? So always, if I know the equation of y in kinetics, if I know the equation of y, dy over dx will be tangent of the angle done by between the tangential direction and the x-axis. Okay? So guys, in fact, let's put this in red. So this is x-axis. This is x-axis. Always this angle alpha here between t and x-axis, this angle alpha here, tan alpha, tangent of alpha, will be dy over dx. It is the slope of the curve at this x. Of course, you know this relation, right? At this x. Okay? So now, guys, I'm going to find dy over dx. Dy over dx is equal to, what is dy over dx? It is equal to minus 20 times 2 times x over 600 for 6400. So it is minus 0.00625x. And what about dy over dx? D squared y over dx squared. Then this will be equal to constant, and it is equal to minus 0.006. From this equation, at x is equal to 80, you can find tan alpha, and then you find alpha. So alpha is equal to what? Of dy over dx, and x is equal to 80. And this means, guys, that alpha is equal to minus 26.57. It is in the negative sign because, in fact, this is the angle, all right? So it is in the clockwise direction. Remember the circle of trigonometry, the trigonometric circle. Now this is the positive alpha, and this is the negative alpha. So if this is x-axis and this is the tangential direction, as our case here, alpha should be negative, okay? So that's why alpha is negative. You can also find alpha in absolute value, all right? So this is your alpha. Why should I use this alpha? Because in fact, if I know the angle alpha between t and x-axis, this will be the same angle between normal and the weight, all right? The normal is perpendicular to tangential direction. The weight is always perpendicular to x-axis. So this alpha, guys, will be the same, right? So the angle between the weight and the normal direction is also alpha, and this will be used in doing the projection. Okay, guys? Now, if I know the squared y over dx squared, I can find rho as 1 plus dy squared dy. Let's write it down. 1 plus dy over dx squared to the power 3 over 2 over the absolute value of dy over d squared y over dx squared, right? So this is the radius of curvature, and you're gonna find that this radius of curvature is equal to 223.61 meters. So whenever you know this radius of curvature, you can find a n that is equal to v squared over rho, because I'm gonna do sum of n is equal to man. V is given in this problem. It is 9 meters per second, and it is in fact constant. So what will be an? An will be equal to 9 squared over this rho. Alright? And what about AT, guys? What about AT? AT should be equal to 0, because in fact, this is a constant speed motion. Now, guys, I can apply the equations of motion in normal and tangential acceleration. I'm going to start by the sum of forces in normal direction, and this will be equal to MAN, and this will give me what? What are the forces in normal direction? It is the projection of the weight to the normal direction, which is a W cosine to alpha. So it is W cosine alpha minus n, of course, the normal, and this will be equal to MAN. This is my first equation. Now the sum of forces in tangential direction is MAT, which is 0, and this means that what are the forces in tangential direction? It is the friction force in the negative tangential direction plus projection of the weight tangential direction, which will be W sine alpha plus W sine alpha is equal to 0. Right? So from these two equations, guys, from the first equation, you can find n, because W and AN are given are known, so it will be 6.7 kilonewton. And from the second equation, you can find the resultant frictional force, that will be 3.5 kilonewton. Okay? Do you have any question, guys? Batul, what if it is traveling over a straight line? We need F, of course. Right? Imagine yourself driving your car. If you are over a hill and you are going downward, you should put your legs on the brake, so that will generate a frictional force on your wheels so that you can stop your car. Now, if you are traveling on a straight line, you should put, of course, you should have an engine force so that you can go in a rectilinear motion. Okay? All right. So, do you have any other question, guys? Okay.